We've had all these problems with normal CDF and inverse norm, but the one thing we haven't had yet is context, some type of real life story problem to be able to attach all of this to. And so that's the last example here. We have the combined verbal and quantitative reasoning score on the GRE is normally distributed with the mean of 1066 and a standard deviation of 191. All right, what in the world? The GRE is an exam. It's actually by the same company that makes the SATs. So you can think of it as an SAT that you take your senior year of your bachelor's degree. So when you're in college, you take this in order to get into graduate school, in order to get a master's degree or something like that. So it's an exam that you take to go to graduate school. I took it, as a matter of fact, to go to graduate school. All right, so it's normally distributed because it's designed that way. It's a nationally normed test. And the normal mean is 1066 and the standard deviation is 191. All right, so now we have to answer all these questions. We're going to give 4 decimal places for probabilities, but only 1 decimal place for scores. So that'll be like X values and things like that. And we're going to have to state our calculator entries and all that good stuff. Okay, so let's start off with the first one. They tell us that we want to know the proportion of combined GRE scores between 800 and 1200. Okay, so the mean is 1066 here. The standard deviation was 191, which is roughly 200, you figure. So 1066 take away 200 is 866. So 800 is just a little bit past the inflection point. So 800 is kind of over here. You just want a way to be able to eyeball it. Of course, StatCrunch will help you as well, right? So, and 191, let's see, if I add on 191 onto this, add 200, that's like 1266. So it's not quite to the inflection point over here. So I'm going to be a little bit shy of it. And so that'll be 1200. And I want to know the proportion that's between, see? Proportion between, so I'm going to shade in here, in the middle zone. All right, let's grab that decision matrix. We already know X values. We know scores on this exam. We know it's 800 and 1200. And we are looking for the proportion. So we're going to use normal CDF, lower upper mu sigma, right here. All right, so that proportion will be normal CDF. Lower is 800, upper is 1200. The mean was 1066 and the standard deviation was 191. All right, so 800, 1200, 1066, 191. I'm going to put that into a calculator. Or, of course, I could use StatCrunch, which doesn't require all that work. But let me put this in first. 800, 1200. Well, actually, it does require that much work. It just looks different. 191. Paste, enter. And you get 0.6767, as a matter of fact. All right, in StatCrunch, I would say between, because this is a between one, I would say 1066, 191. This number was 800. This was 1200. I was given X values. So I'll put them in there in that parentheses. And there it tells me the answer, 0.6767. And notice that graph matches the graph we have. Very nice. All right. Now, suppose the Department of Psychology at Columbia University, which is an Ivy League school in New York City, as a matter of fact, very expensive, very prestigious. It wants to accept only the top 10% of all test takers. What would be their cutoff score? So they're not even going to look at you unless you're in the top 10%. Okay, so let's see here. There's a number over here that cuts off the top 10%. So that area would be 0.10, the top 10%. What we're looking for is what's that score? So say you're a student finishing off your bachelor's degree and you want to get into Columbia for psychology. What you're trying to figure out is, hey, what do I need to score for them to even look at my transcript? How high do I need to go? Right? Okay, well, let's look. I already know an area. I know a percent. It's the top 10%. So I know my area, but I'm looking for my x value. I'm looking for my score on that test. So it'd be inverse norm, right? All right, so this is inverse norm, and there's two ways to do it on a calculator. If you have a newer calculator, you can say 0.10, 1066, 191, right, because that's the right area, the right tail area. If you have an older calculator, you don't have that option. You have to find the area to the left, which is the complement, right? 1 take away 0.10 is 0.90, and that's what you'll use instead. On StatCrunch, it won't make any difference. You can use either one because StatCrunch is awesome like that, right? And this one is the one most TI-84s have to use. And let's see here. Second inverse norm. I can say 0.10, 1066, 191, right. Paste that in. Enter. I could have said inverse norm 0.90, leave the 1066 and 191 and make it left. Again, that's standard. Most calculators just do that by default. If I'm in StatCrunch, the tricky bit about StatCrunch, you have to choose, it's not a between anymore, so you click standard, and then it's your choice. If you want to do less than, do less than. If you want to do greater than, do greater than. So if I want to do greater than and say 0.10, enter. There we go. You put the area over here, and it'll give you the x value. If I want to say less than and say 0.90, enter. There you have it. Either way will work. Right? That's essentially what you're doing when you do this problem. So 0.10, you're choosing between those two graphs, those two methods. And we get 1310.8. Right? It said to round to 1 decimal place, so we did 1 decimal place for that one. All right, what about the percentile rank of a student who scored 1100? Ooh. Okay, so this isn't going to be too great because a 1066 is the mean. If you scored 1100, you're just a little bit above that, right there. The percentile rank, remember, is the percent below you. And we round it. All right. Well, so let's see here. I want this area right here. This does not mean you did well on this test. I mean, you didn't do horribly. You scored above the mean, but it's not great. All right, where am I going to go? I already know my x value. My x value was 1100. I'm looking for percentile rank, so I'm going to use normal CDF. Right, so normal CDF. Lower, comma, upper. Well, remember, if you're shading the left tail in normal CDF, you'll use negative 1E99. And so we will. So this will be normal CDF, negative 1E99, and then 1100, because that was the upper end, 1066, 191. If I put in those values, it will give it to me. So 1100, 1066, 191, and I get 0.5706. So this is 0.5706. It's not the answer. We want to round the percentile, so it's P57, or the 57th percentile, which I realized I forgot to do in that one problem a while ago, but I remembered eventually. So you round, make a note. We said it on a previous page. It was in a little box, actually, but we round percentiles. Now, in StatCrunch, if I want to do that same problem, 1066, 191, I'd make it a less than, and I would tell it 1100, because I know the x value, so it goes in here. X values go here, areas go over here. And it tells me 0.5706. Done. All right, last one. Ooh, another middle one. Those are the tough ones. Okay, so we want the center is 1066, And then we have two values that cut off the middle 95%. See it? So this area right here in the middle is 0.95. Okay, these are the ones that are a lot easier in StatCrunch and newer calculators than they are in the older calculators. So I'm going to show StatCrunch and the new calculators first, and that way if you have those available to you, you can skip the whole old calculator thing. All right, so let's see here. StatCrunch. It's a between one, so I'm going to click between. 1066, 191, and I'm going to go over here and put in the area of 0.95. Enter. And there you have it. 691.6 and 1440.4. That rounds because that's a 3.5 in case you're missing it. All right, now, what if I have a calculator instead? Well, let's see. If I look at that area, you can see it on the StatCrunch. I'm using, first let me go grab the decision matrix. I'm looking for an X value. I'm looking for a score on this exam. So it's going to be inverse norm. But if you have a newer calculator, you don't have to deal with the old left tail area thing. You can say, second, number 3, say 0.95, 1066, 191, and choose center. That's the same thing that StatCrunch is doing. And so when I press enter, it finds it. Okay, so let me type or write those answers in. And then if you're not in an old calculator, you don't have to follow along. All right, so we're doing inverse norm. And we're saying the middle area is 0.95. It's the center area. So 0.95, 1066, 191, center. And that gets us our two answers of 691.6 and 1440.4. So the middle 95% of students scored between 691.6 and 1440.4 points. Right. Okay, now what if you have an old calculator? What are you stuck doing? Well, you have to find each of these tails on its own. All right. So the middle is 95. The whole thing is 100%. So if we take 1 and we take away 0.95, we have 0.05. So what you're going to do is take 0.05 and split it in half for both of these things. This is actually such an important calculation. We do it over and over in chapter 9, but you'll see it there also. And 0.05 divided by 2 is 0.025. If you don't believe me, I'm more than willing to show you. 0.05 divided by 2. There you go, 0.025. All right, so each of those tails is 0.025. So then if I'm going to use the the older calculator, I have to use inverse norm. I'm going to have to do it twice. I have to do the one on the left, which is 0.025, comma 1066, 191. Right? What you're doing is a left one. That'll get you the 691.6. Here, I'll prove it to you. Second distribution, inverse norm, 0.025. 1066, 191 left. Again, old calculators don't have that option. Everything is left for an old calculator. All right, so that's 691.6. The harder one is the one on the right. So inverse norm. And then you need a number to put in. And it's not a number that's sitting out there for you. It's not 95 because that's just the middle portion. It's not 025 because we just did that one. It's the two of them put together. It's everything to the left of this value. So that would be 0.975. Here, 0.95 plus 0.025 makes 0.975. So then if I do inverse norm, 0.975 and left, there you have it, 1440. So if you have a newer calculator, don't gloat. They're a lot easier, and that is the truth. But that's okay. So this is 0.95 plus 0.025. You don't have to use a calculator at all. You can just use StatCrunch. StatCrunch is also much easier than doing this whole thing. But there you have it. All the same stuff we're doing and using that decision matrix, inverse norm and normal CDF, but we have context and a story problem to attach it to. So that makes it more fun, right? Well, maybe not.